apart from the information you get from this course, it would be worth taking a look at some reference documents of the board, like the microcontroller datasheets. For instance, it's fairly standard. Any new hardware you buy, you have to take some time to look through the datasheet. As we go through this course, yes, we're going to go through the datasheet together to extract just what we need. Don't worry, the datasheet is quite large. You don't need to memorize it, you don't need to learn it at all. It's just a reference manual, like a sort of dictionary. If you want to do something, you go and check in the datasheet. So it's worth downloading it and having it on your computer. Another one is the Tiva C Launchpad User's Guide. That's also worth a read. And yes, finally, we are ready to write our first assembly code. How excited are you? I'm certainly excited. I remember the first time I wrote assembly. Yes, so our first program is fairly simple. It's called the red on. What this does is the red LED. Remember, we have the RGB. We have green, blue, and green LED already on our board. What this program would do is keep the red LED on. It doesn't blink. Remember, when you buy the board, there is a program that makes the light blink on it. This first program we're going to write is going to keep the light on, and we're going to write it in assembly. Then after that, we improve this program step by step. We start adding things to it. Any well-structured program must begin with a requirement document. Yes, I think it's important to have a requirement document for every program. So we'll start this first one by trying to write down some requirement analysis for this program. And as we go on, this is a very simple program. In fact, we don't even need to write such a document for it, but I think it's a good practice to do. Yes, so we just go through some of the things we write in a requirement document here. The requirement document involves determining the needs of the system through asking questions. Let's see some of the questions we can ask. What is the objective of this project? Yes, it is to design, build, and test a system that turns on the red LED. How will the project be developed? The program will be written in CAL-U Vision, developed using a Tiva C Launchpad. How will it fit into existing systems? The red on program will be callable from systems having the same microcontroller. That's good. What will the system do precisely? Yes. The system will start by setting up the required pins on the board and then enter an infinite loop that keeps the red LED turned on. So there's a fairly, very short requirement document, but I know you understand. Based on this, if you write in a bigger program, you would know the questions to ask. This is just to give you what such a requirement document would. Now, let's take a look at the project setup. Every CAL-U Vision project contains two files that, when you create a new project, comes along with it. And these files are the same file written in C and then assembly. And what these files do is that they set up the starting point of the program. They have what we call a reset handler, the block of code that is run every time you press the reset button. Also, these files outline the stack size and the heap size. I know we've not talked about stack and heap. We'll talk about them later, but I just want you to know the functions of the startup files. And without these files, you cannot compile your program. You would receive error messages. So when you create your project, you get these files. They also contain the reset vector and all interrupt vectors. We will talk about interrupt later. As we mentioned earlier, the reset handler runs every time the reset button is pressed on your microcontroller board. And what this does is that it jumps straight to the start point of your program. And in C program, in code written in C, the start point is the main function. So what this means is that if we're writing our program entirely in assembly and we want the program to start from the assembly side, we would have to go to the reset handler and change the starting point to the starting point that we give our program. We would see this when we create our program.